Prove that the absolute value of sine x is less than or equal to the absolute value of x for all x in R. And we're going to do it using mean value theorem. This is an interesting and useful proof. Like we've been doing, we're going to construct a function, but we're just going to construct it with sine x. So define g of x to be sine, instead of using g of x, I'm going to go g of t, actually, because I want to use mean value theorem and bring the x in after. G of t to equal sine t for the interval, or on the interval 0 to x. That's how we'll introduce x in. X is a real number. All right, we know that g of t is both continuous and differentiable. I'll state that. Since g is continuous and differentiable on my interval, we can say by the mean value theorem, there exists a c between 0 and x such that the mean value theorem says that g prime of c is equal to g of x minus g of 0 divided by x minus 0. Sine of 0 is 0, x minus that is just x. So we get sine x. Yep. Over x, sorry about that. And we know that the derivative of g at c is equal to, let's see, cos c. And I'm going to multiply x over to get sine x equals x times cos c. And we'll take the absolute values of everything. And we can split the absolute value. And cosine is always bounded above by 1. So we know that this is less than or equal to that, just absolute value of x. And this is for the interval from 0 to x. We can say that a symmetric or similar argument can be made for the interval from y to 0, because we want all real numbers, and so we can make the exact same argument but from y to 0, and we get the same thing, and thus we can conclude the absolute value of sine x is less than or equal to the absolute value of x for all x in the real numbers. That's the proof.